In this problem, we are told the magnitudes of two vectors. One is 3 meters long, and the other is 4 meters long. And we're not really given any other hard information about these two vectors. We're not told what angles they're at, we're not told anything about how they're arranged. Instead, the problem is asking us to determine that. The problem is asking us to figure out how these two vectors would need to be arranged so that they could add up to give us some resultant vectors of some different magnitudes. So really, this is just a problem that's making sure that you understand how vectors add together. Part A of the problem is asking us to consider how these two vectors could be added together to give us a resultant displacement with a magnitude of 7 meters. And really, if you think about it, there is only one possible arrangement that would give us that resultant. Because notice, one of our two starting vectors, one has a magnitude of 3 meters, and the other has a magnitude of 4 meters. And we're being asked to find out how they can add together to give us a resultant magnitude of 7 meters. And note that 7 is really just 3 plus 4. So 7 is the resultant displacement we get when our two starting vectors add together perfectly. And this can only ever happen if the two vectors are parallel to one another. If the two vectors were at any sort of angle with respect to each other, then they would add up differently. But if the resultant vector is a perfect sum of the components, then all the components must be pointing in the same direction. So if we have the 3 meter vector, and it immediately leads into the 4 meter vector in the exact same direction, parallel, then that would give us a resultant vector with a magnitude of 7 meters. So for part A, we would expect the two vectors to be parallel. Now part B asks us to think about how the vectors must be arranged to give us a resultant magnitude of 1 meter. Note that this is smaller than both of the individual components, so our two starting vectors should be canceling each other out in some way. And once again, if you think about it, there's really only one arrangement here that actually makes sense. We're looking for a resultant magnitude of 1, and our starting components are 3 and 4. 4 minus 3 is equal to 1. So the resultant magnitude of 1 is something we would only get if the two vectors are perfectly canceling each other out as best as they can. So in other words, they'd have to be anti-parallel, or pointing in perfectly opposite directions. So for example, let's say our starting point is here, and the first vector, the 3 meter vector, points to the right 3 meters. And then next we're adding this to a vector that points to the left 4 meters. And this displacement from the starting position represents 1 meter. So this is the result we'd get if our vectors are oriented in a way that is anti-parallel. Finally, part C asks us to consider how the vectors need to be added to give us a resultant magnitude of 5 meters. This one's a little trickier because 5 is less than the sum of them being parallel, but still more than the sum of them being anti-parallel. It's somewhere in the middle, which means there needs to be some angle between these two vectors. This part might be a little harder to figure out without a bit of trial and error, but one very common arrangement for us to see a set of two vectors in is for them to be at right angles. So one thing we can try is to use the Pythagorean theorem to say that they're at a 90-degree angle with each other. So we can imagine a case where maybe this is our 3 meter vector, and then maybe here is our 4 meter vector. So there's a right angle between them. So the two vectors are perpendicular, which you represent with this little square. In this case, the resultant vector would be this line right here, forming kind of a right triangle with a hypotenuse. And when we have a right triangle, we can determine the length of the hypotenuse using the Pythagorean theorem. And the Pythagorean theorem states that the length of the hypotenuse is going to be equal to the square root of the sum of the squares of the right triangle's leg. So that would be the square root of 3 squared plus 4 squared. And if we put that into a calculator, then we find a hypotenuse length of 5 meters, which matches up with what we're trying to find. So the answer to part C is that 5 meters is the resultant magnitude we get when the two vectors are perpendicular. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. And if you have a request or a question, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you all have a lovely day. Bye-bye.